Hello. So we're back Tuesday morning and we have to fix something. We have a job from someone who knows the channel. And I just spoke with the gentleman over the phone, a nice guy, and he explained me about the laptops, and also he sent me the laptop and he sent me another two boards to have spares. He said, you know what, I seen in your video you use spares. And he sent me exactly the same boards for this laptop. Yeah. Also, that's not all. He sent the schematic and the board view. You can believe that? Now this is like 99.9% this laptop will be done on this video. Okay? So let's have a look. We have a Chromebook. I don't have the charger. But we don't need a charger. We have the power supply, so we can use the power supply. Let's see. So he's taking 1 amp. That means he's charging. Okay, so he's taking 1 amp on the power supply. Power button is here somewhere or not? Let me see, where is the power button? It is there. It's here. One more time, 1 amp, pressing the power button, and nothing happened. So looks like the laptop is charging. You know how it is? I feel so bad when I repair things from the people know me. When someone doesn't know you, you can't fix it. You know, it's okay. But to tell someone which he knows me, you know, I can't fix it. It made me feel so bad. Okay, so let's open this one and have a look. Few screws are missing. Let's see if we can help me. He sent 2 laptops, so we have 1 more. But the problem is, on my laptop, I have exactly 0 schematic. Because it's not really time to open the schematic and try to fix something with the schematics. Huh? Yeah. It's no time. Okay. So we have a ribbon cable with the back cover together. So what do I want to check first? Because the laptop is charging. So you have a charging board. On this case, you know your main power VCC power rail is good. You know the 3.3 volts is good because it's charging, you know, so most likely every voltage is fine. So either we have a dead Super IO startup chip or a faulty power button somewhere. It's something, it's with the startup sequence is not going right. So what do I want to check first? I'll take the multimeter. I want to check the power button. We do have 2 more boards there, so if we need spares we have. So we should have 3.3 on the power button, okay? We have the ribbon cable is connected. Hopefully the battery has voltage, but we can check. The battery has 8.8 volts. We do have voltage. And on the power button we have 3.3, and that's bad. Hopefully the power button is broken, because otherwise, like how I said, can be a Super IO issue. So I'll check the 3.3 and I'll press the power button on the same time. And 3.3. Now let's push the button and it's going to 0, so the power button, it is good. Okay. That's bad. You know, that's the worst case, when everything is fine and it's looking good, but actually it's not working. I think the easy way, the easy way, you know, let me try and not do the same mistake like the last time. You remember the last time? So I was spinning around with the gaming laptop, and actually it was a faulty SD card reader. Let me unplug everything and try to check one more time. We don't need screen because you can see based on the current reading if it's starting or not. I should open the laptop because we have the proximity. We have the Hall sensor, for the lid when it's open. No, not the multimeter. The power supply. The power supply. So we need a good ground. Plus on the charging port, and it's taking 1 amp. Let's push the... Why is going to 0? Let me find another ground. Okay, that's better. Let's push the power. No, it's going to 0 again. Okay, let's push the power button. And the board is still not coming on. It is charging, but it's not coming on. Okay? So it's not working. But I know my track is good from here to the startup chip because I have 3.3. Okay? Good. We can unplug the battery eventually. Let's unplug the battery, and we have like 20 milliamps. Let's push the power button, and it's nothing really happening. Okay? So this board doesn't look promising. So what I'll try to do, let's test the other two boards, because we have two more boards, the same. So are the same boards. So I think it's more easy. Motherboard is short. Okay, this looks promising. And here is not saying anything. Well, this looks okay. Motherboard is short. That's a high chance to be fixed. Just because it's shorted. So let's have a look together. Let me check with the power supply first to see if it's taking any current. So you have the power supply. Wow, it's taking 2.3 amps. Two point 2.3 amps. And it's melting. It is a semiconductor. Seems like. This is not capacitor. Let's go high with the current. 3 amps, and it's smoking. Now it's smoking. You can see a lot of smoke here. And we have a shorted MOSFET. You can see there? No, you can't see. That's good. You see? Always when it's above something is shorted, it's a good sign. Actually, you can fix it. Let's have a look together. And the easy way is to smoke it out, you know, go high with amps and yeah, so clearly that MOSFET is gone. Let's replace that MOSFET quickly because we have the other boards. Or we should check the second board. No, I think we are fine with this board. Most likely this is the only fault and we can fix it. Yeah? Okay, so that's the burn MOSFET. Let's see the other one. Let's get the MOSFET from here, from this board. We should replace the both MOSFETs. Do you think it's shorted? The second one is shorted? Let's check. Let me grab my multimeter. Well, it is shorted. You can't see it. So both MOSFETs, they are shorted. Or we have a shorted power rail. Okay, so we are on a diode mode, source and drain from the MOSFET, and we have 0, 0. You can see. Okay. I believe it's a better idea to replace both MOSFETs. Or to remove this one and check for short. So this one is out. Let's check for short now. So from the coil to the ground. And it is short. So actually the second MOSFET, it is good. But the power rail is shorted. Now you understand why the first MOSFET blow up? Okay, let's get the power supply. Can be the RAM power supply, yeah? Can be the RAM power supply. So I'll go with 1 volt. Yeah, I'll go with low voltage. Now let's see what's happening on the output of this coil. 4 amps. Okay, let's lower the amps. Hopefully it's not the RAM, because if it's the RAM, we have a big problem. We can't fix it. This is a bad sign. So here is something extremely warm. Well, everything is warm on this board. Still don't understand. Everything is warm here, but it's not the processor. Oh, the processor is cracked. What a waste of time. The processor is blow up. You can believe that? Let's have a look together. So check there. The processor has a big crack on it. But it's so big, I can, look, I can, yeah, so most likely, this will not gonna work. I'm so disappointed. This board was looking promising. Well, yeah. Okay. Okay, let's go to the next one. Next one is another board. The processor looks good on this one. Let's go with the power supply. 19 volts. And it's taking nothing. Like nothing. Okay, let's get a multimeter. Maybe from this side, yeah? Ground. And the second ground for the power supply. We have the power supply is this, and this is the meter. Okay, well, let's check. We have a diode, 2 MOSFETs, and after the second MOSFET we have 20 volts, which is right. So our 3.3 volts power supply is not working. Huh? What do you think? Our main power rail, it is present everywhere. Okay? Now it's a question there. Yeah. The question is why your 3.3 volts power rail is not working, and the easy way is to check if our 3.3 volts power rail is not shorted. So we have 3 volts, and we have 2 BIOS chips here, and that will come on the pin number 8. This is not shorted, and this is not shorted. Okay, so actually our 3.3 volts power rail is not working. Now we simplify the thing. All we have to do is to find the 3.3 volts power supply. How do we find that? Let's get a multimeter. Okay. And let's see. First, if the pin number 8 from this BIOS chip with this pin number 8 from here are together. And they are not together. Okay. Next step is to find if this pin is going with any coil. Okay. We have a coil here. Sorry, it's voltage. Let me change on that. Let's see. So one more time, these are together, are not together. So this pin is going in to any coil. Nothing. 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 Let's try to find the 3.3 volts power supply. Nothing. 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 And that's all. We don't have more power supplies here. Okay, it's not necessary to be a coil. In most of the cases, it is coming from a chip. So let's have a look for a chip which is looking like a power supply. Or, yeah, but that's right. That's okay. That's fine. Let's try another trick here. Let's try another trick. Let's check from the other one. Not this one, not this one. No. No. Okay, that's bad. I will take my beeping multimeter, and we have here one chip here, and it's not beeping, and we have the second chip here, and it's not beeping. That does mean this BIOS chip is not getting the 3.3 straight from the power supply. Well, let's check if it's a common track with the Super I/O, with my startup chip, which is a SMSC. This one has a common track with the Super I/O? No, it doesn't. Okay. Okay, let's see the Super I/O. Ground plus. So this one, it's with this one, is not. It's not with this one. This one, that's plus. Okay, this one with this one are together, so most likely here has to be 3.3. Is together with any BIOS pin? No, it's not. Okay, so this is the 3.3 volts voltage for the Super I/O. So let me try and beep it and see where this track is going. Okay. It's going here. So this is our 3.3 volts power supply. Okay. Let me check with other multimeter for you to see. So that's how you diagnose without the schematic, yeah? We do have schematic, we don't have time for schematic. So we have this pin, which is most likely is the 3.3, and we have this power supply, and it's 0, 0. It's a small resistance. Is with the ground? No, it's not with the ground. Yeah, so we have this power supply here. You see coil, and you have this chip and this power supply with this capacitor, which is next to the startup chip, has a track together. Okay. Now, to confirm the theory, yeah, just to confirm it. Just to confirm what we spoke, yeah? So we said, okay, this is our 3.3 volts power supply. Just to confirm, we have a working, half working board, this one. This one which is on the laptop. So the battery is plugged in, we should have 3.3. But we can't check because the board is, okay, we have to take the board out. Okay, let's take the board out. Just to check our theory. So we said that that's the one is the 3.3 volts power supply. Let's check. We got the things right or not? Okay, so we took out the screws. Let's take out the connectors. The speaker connector, the battery, and that's all. And the board is kept by the hinge here. Let's open the hinge. I think we have to take the hinge out. Okay. That's the board. Let's plug the battery in. Now let's have a look on the other side. We said that's the one is the power supply, the 3.3. Let's check with the multimeter. And we have ground. And we have no voltage. So does mean this is not 3.3? It's not. Okay, let's check the BIOS chip for 3.3 and it's not 3.3. Let's check this one for 3.3 and it's not. I don't think this is working. So how do I have 3.3 on the power button? And on the battery we have 0. Okay, that can explain why we don't have 3.3. Let's charge the battery a little bit. Ground. Okay, the battery is not taking current. Let's go with 19 here. This is not ground. No, it's not. So that thing is not ground. Okay. So let's check one more time. But this thing is not ground. So let's check the battery voltage, the power supply. Check on the multimeter. Check on the screen. It is 3.3. What did I told you? I told you this is the 3.3 volts. And like how I said, on this capacitor I should have 3.3 here. Can't read. No, not on this one. On this one. So one more time. and I don't have 3.3. I think the battery is too low. The battery is too low. And it is charging 1.2, but I think the battery is too low. I don't have the charger. Because I'm curious about something, and I will tell you what. So we do have 3.2, you can see on the screen. I'm curious how the BIOS has the voltage, yeah? So this is the last pin and the BIOS has 3.2. But the BIOS is not the same track with this, but it still has 3.2. So it's probably somewhere that is some kind of diagonal serial mode or a switching device. So our conclusion is this is the 3.3 volts power supply, which is not on this board. Okay? So the next step, I'll unplug the battery. I'll take this board. Let's plug the battery. Let's be sure we have voltage. And then see why this 3.3 volts power supply is not working. So our main power rail has nothing. So our main power rail has nothing, no voltage on the battery. But the battery is charging with 2.3 amps, which is right. Let's charge the battery a little bit. Okay, now let's check the voltage. And the voltage is 9.3. Now let's check the 3.3. And we have no 3.3, you can see. Let's have a look closer on this power supply. Okay, because we know the power rail is not shorted, we check that. This one is not working. Let's check if we have 9 volts on the input of this chip. And check on the multimeter, we have 9.2, but the chip is not working. Most likely the chip is dead. So what we will do, we replace the chip quickly. I'll unplug the battery. I will take this chip out quickly, yeah? Because we already spent some time here. Most likely the chip is dead, because like I said, it's not short. The power rail is not shorted. Can't really see another reason why this chip is not working. Okay, so the chip is out. Now let's take the chip from which board? From the one with the cracked processor. Hopefully it's good. So now let's get the chip from here. Okay, I will lower the temperature from 500 degrees to 430. Just to be sure we are not burning the chip. So the chip is out. Let's move the chip on this board. I can't. Good. Good. So the chip is soldered. Now all what is left is to test. Okay, let's see. Let's wait to cool down. We know if it's working when we are coming with 90 volts on the charging port and we are seeing there like 10 milliamps, 20 milliamps. So we know that chip is working. Otherwise, it's not working. Okay? So let's see, ground, plus, and nothing. Really? That's bad. Let's plug the battery. Let's check the voltage. That's bad. So the voltage on the board is nothing, is zero. Let's charge the battery a little bit. And we can't charge the battery because the battery is not charging. Yeah, why not? Okay, let's come with 19. But this is not 19, this is my multimeter. Try one more time. And the battery is charging with 2 amps. Good. Let's check with the multimeter now on that chip. So the input of the chip is 9.2 and the output is 0. The chip is still not working. I suppose that chip is good, but it's not. Because we took the chip from that board with the CPU which is exploded and the MOSFETs they are exploded. So I'll replace this chip now, yeah? I'll replace this chip with the one from that working 3.3 volts power supply. Okay, so I will leave this chip on one side and I will take it from the board which is working. So we have this board, and on this board we know 100% this chip is good. Okay? 100% this chip is good. Okay? So we got the chip. Let's move the chip. The chip is soldered on place. I can't see any short there. We are fine. Let's see. Let's get the power supply 19 volts. And it's still taking nothing. How this is possible? What I'm doing wrong? Battery discharging. The output is 0. The input is 9.3. Let's take the power supply. Three volts, ground and output, and it's not short. Well, I suppose it's time to have a look on the schematic then. I have no glasses. Okay, that's the input part. And we have two MOSFETs. And we have the thingy. And we have the charging circuit. Well, let's find the 3.3 volts power supply. That's another input. Okay, what's this? Yeah, that's the one. 5 volts and 3.3. Good. I don't think this is the schematic for this board. I don't think this is the schematic. You know why? Maybe it is. Anyway, 3.3. Let's check. That's 5 volts, and this is the 3.3. Okay. We don't have so many pins. Looks like, but this is not the schematic. The schematic is this. Chromebook. Acer Chromebook. C538. Yeah, that's the one. Oh, I'm pretty sure it's not this one. B30 3B30. Let me check online. 3B30. No. 1 second. 12A. RT chip. You get me lost here. RT. We have a look online. RT 7290. That's the chip. That's the one. Sick. Okay. Let's see, what do we have here? We have the enable pin. And the enable pin, yeah, pay attention. The enable, this is 3.3 volts enable pin, yeah, you can't see, is coming from the power good of the 5 volts, yeah. So in order to have 3.3 we should have 5 volts first. Okay, let's have a look for the 5 volts power supply. Let's see. We have a shorted USB. No. So 5 volts. Well, 5 volts has a protection, as a chip. So 5 volts. And is this, you can't hear the beep. So this is the 5 volts power supply. Oh no, this is ground. What? Why this is ground? Wait, where is the other this is no ground, but this is ground. Yeah? Give me one sec. Okay. Why do we have a short there? Let's see, yeah? This one is shorted. Because because the CPU is shorted. But it's not the 5 volts. You know what? Let's move the chip back and let's replace the Super IO. It's more easy. Actually, I don't have to move this chip back. I can use the chip I took out. Let me check the chip position. Yeah. So let's fit the chip back on this board. Yeah. Oh no, this is a MOSFET. What I'm doing here. That's the chip position, okay. So the chip is soldered. Let's see if it's taking power. 19. And it's taking 170, 160. So clearly that chip is working, yeah? Let's plug the battery. Let's check the voltage with the multimeter. It's no voltage output because there's no voltage input. That's probably the battery is low. Let's check if it's charging, yeah? And it's charging 1.2 amps, you can see. Okay, let's replace the Super I/O. Yeah? We can do it. We can do it. So the Super I/O is this. You see, that's good we have spares, because otherwise I don't know what I will do. Okay, so the Super I/O, but this is a weird one. I swear it's a weird one. What's this thingy with 2 rows of pins? Okay, the chip position is like that. Good. So let's get the Super I/O from this board. Okay. You know what I'm thinking? I'm thinking I should replace the BIOS chip first. You know what I mean? Because maybe it has a software issue. This is a weird super. Come on. It's okay. It's not straight, yeah? Let's see. Let's see. Should be working, right? It is charging. It's on and it's working. I can't believe that. So actually we did have a faulty Super IO. And it's working. What is left to check, with the keyboard it's working and everything. But this is a crazy fault, so I spent over 1 hour on this thingy. Over 1 hour. Can't believe. But at least we fixed it. So, you know, that's what is important. Let's check to be sure it's working, yeah? But crazy, again, crazy Super IO. You can see the marks on the board. It's like 2 rows of pins. And it's in for the Super IO? Really? Just for testing. After that I'll finish the job after that, because this is already long. Okay? A crazy job, crazy long job. Doing a lot of mistakes. Because why not? Let's see. 19. What's wrong with my power supply? It is working. Why it's not taking no current? Even the hinges. I have to put the screws on the hinge. But let's see. Let's see first, yeah? Let me see. It's not taking power. Why is not taking power? Why is not taking power? Now it is taking power. So what did I take out? The battery, yeah? Yeah. Give me 1 second. Okay, let's see one more time, yeah? Yeah, I'm in rush. I'm in rush because I have a lot of jobs. And we have the blue light and the orange light, and the laptop is on. The laptop is on, but why is not charging? What I'm doing out here? Okay, 1.3 amps. Let's see it on. We have the battery sign on the screen. The battery is too low. The battery is too low. But the charger now is plugged in, so let's power on. Give me 1 second. Okay, so it's working. The mouse is working, but the mouse is connected to probably straight to the PCH. Let's see. The keyboard. So if you press connect, the keyboard seems to be working. We really need the password. Let's try the password. Yeah? Connect. The Wi-Fi is working. That's good. I didn't put the screw there. Sign in, and he asked me for. Sorry, it's an email address there. It is working. Okay. It is working. Let me go back. It's working great, so at least we fix it. But these small laptops are crazy. Yeah, I shut it down. It's still charging. This is great. This is insane. Like it's over 1 hour, 1 hour and 15 minutes. I can't believe that. 1 hour and 15 minutes for this thingy. Yeah. So actually, this was faulty. This is a startup chip, the Super I/O on these laptops. So this was faulty. And I soldered back the other one from this board and was working fine. But this board has a short, which I said it's on 5 volts. But even if I applied voltage here, the processor is getting hot. So something is it's more damage on this board. It's not compared with the boards here, it's not supposed to be 0 ohms. But anyway, and when I came with the power supply, the processor is getting hot. So it's possible to have a shorted processor, and this one with the blow-up MOSFETs, we have a blow-up processor, which is, you can see it has a chip on it. But insane amount of work on a laptop, but at least it's fixed, so we can hopefully the customer is happy. We can only hope. Yeah, it is working. Yeah, all keys are working. The touchpad is working, which is okay. I have to put back all the screw eventually to clean the board. Yeah, the battery is low. That's okay. That's normal because the battery is low. But it's working fine. Okay, so I'll stop now because it's the lunchtime break. And see you on the next one. I'm really sorry for this long video, but not every job is like straightforward. Okay, so see you on the next one. Bye.